Alright guys, this one is on enzymes, which is an example of a protein. Remember, proteins are a type of organic molecule. Enzymes are really important, so they get their own video. Enzymes act as a catalyst, which if you remember from physical science definition-wise, they speed up a chemical reaction by lowering the activation energy, and they do that without being changed. So they themselves do not get changed during the reaction. This picture here shows kind of what happens. So this blue line, this blue curve, shows what happens when there is no enzyme present. And you can see the amount of energy it takes. So this blue line with the arrows at the end show how much activation energy is required. And activation energy, if you think about it, how much energy is needed to activate or to start the reaction. So in this blue reaction, or this blue line, it takes a lot of energy. Okay, now this red line is showing what happens when enzymes are present. And you can see there's a lot less activation energy required. Okay, so these enzymes are going to allow the reaction to happen much faster than if there were no enzymes present because they lower the amount of energy needed to get started. Sometimes if enzymes aren't present, they can never make it up this hill. It's just too steep. Okay, so they can't allow the reaction to happen, but when they add that enzyme, the reaction can happen much faster. Okay, so enzymes speed up a chemical reaction by lowering the activation energy. Now enzymes are very unique. They act with only certain molecules, very specific molecules. So every enzyme has an active site. Okay, so I'm just going to draw a generic one for you. Okay, so here is a generic enzyme. Okay. Alright, so this area right here represents the active site. Okay, so this area in here, draw like that, is the active site. Alright, and it can, again, can only interact with certain molecules. So over here, I'm going to draw what is referred to as a substrate. Okay, so this substrate, if you can see, is the same shape as this active site. Okay, and so they can combine together. But if I had a substrate that looked like this would not fit into there, and so it would not fit. It would not react together. Okay, so in order for an enzyme to work, it has to be very specific, and it works with an exact match, kind of like a puzzle piece. Or in this case, you guys can see here on the slide, it's called a lock and key reaction. If you have the wrong key, it will not unlock the door. Okay, so the substrate and enzymes work together very specifically. Only certain enzymes work with specific substrates. Okay, in physical science last year, your substrate would be referred to as your reactants. Okay, so if your reactants do not match with your enzyme, you're not going to get a product. Okay, we're using those terms from last year. Okay, so a lock and key reaction has to happen. Okay, once these come together, the reaction happens. And then when the reaction is done, this molecule may be split apart, but this one still stays the same. So nothing happens to your enzyme during a chemical reaction. Okay, so that's really important. Some things to remember, keep in mind about enzymes. Oftentimes they end in the term ACE, A-S-E. Okay, remember from carbohydrates they ended in ose, which meant sugar, but for enzymes they end in ACE. Okay, so carboxylase, amylase, all of those are examples of enzymes. Okay, again, enzymes are very specific. Not only do they work with specific substrates, but they also work under very specific conditions. Okay, so the temperature has to be just right. The pH has to be just right. If those things do not happen, if the enzyme gets too hot, for example, then it can become denatured, which means this active site is no longer going to be correct. And so this substrate cannot interact with it anymore because it no longer fits. Okay, so if an enzyme is in a condition that it cannot handle, it becomes denatured. Okay, there's the word right here. It becomes denatured. Okay, so extreme heat extreme pH can cause an enzyme to become denatured and it no longer will work. Okay, so in this picture, you can see what's happening. Okay, so this is showing 3 different enzymes. This is pepsin, which is found in your stomach. This is amylase, salivary amylase, which is found in your mouth. And this is arginase, which is found in your intestines. Again, you can see it ends in ase, so it must be an enzyme. All right, and then if you look here with the pepsin, it works best when it is in an acidic environment, and your stomach is acidic, pH of 2. Your amylase works best in a pH of 7. Your arginase works best in a pH of about 10. Okay, so these enzymes work best at specific pHs. If you take them out of their normal pH range, you can see here, it becomes denatured, and so you do not get a good product. With your amylase, if it's too acidic or too basic, it no longer works the way it's supposed to. Okay, so if an enzyme is in a condition that is not optimal for it, it will become denatured. But if the conditions are good, then it will work like it's supposed to. Going back to temperature, if you think about the molecules when it's cold, they kind of move slow, right? They're just slowly moving. And so every now and then they might bump into each other to cause a reaction. But not as often as if it gets warmer and it's running into each other more often, right? And so you get more product as it gets warmer. But when it gets too hot, your structure changes, okay? So it can no longer bond. And when that happens, it's denatured. Okay, so really hot temperatures denature enzymes, but cooler temperatures don't really denature them. They just cause them to move so slow that you don't get a good reaction. Okay, so this is a very quick version of enzymes, extremely important. All the reactions that happen in your body require enzymes in order to do that.